Lesson, we're going to go through 5 or 6 area from the textbook. Okay, so the first section is unit conversion. I think even though they're laid out here for you, I would not personally try to memorize this one, because this is really just from the normal one, right? So from kilometers to meters, meters to centimeters, centimeters to millimeters. This is the one you need to remember. You also need to know 10,000 meters squared is 1 hectare. So these are the two things you need to memorize. So let's see how we can use it without memorizing the one I crossed out. So for example, 55 meters squared, 2 centimeters squared. First thing you need to know, 1 meter is equal to 100 centimeters, right? And because the unit now changes to squared, all you need to do is square both sides. So this will give you, on this side, 1 squared is just still 1, right? So 1 meter squared is equal to 100 squared centimeters squared. So 100 squared is 10,000 centimeters squared. Now you have 55 meters squared. So you put 55 on the bottom. How much is x? And then you do cross multiply. I think that's easier than memorizing that. So x is equal to 5540 centimeters squared. Alright, next one. So this many centimeters squared to kilometers squared. So first you need to know 1 centimeter. So 1 kilometer. 1 kilometer is equal to first 1,000 meters, and then from meters we go to centimeters, right? So 1,000 meters is equal to, times this by 100, there should be 5 zeros, centimeters. Now we need to square this. But then the only two parts you need is kilometers and centimeters, right? So write them down. So 1 kilometer squared is equal to, that's 5 zeros. If you square it becomes 10 zeros. You just do 5 times 2 in the bracket. And you will see that it's 1 and 10 zeros. 5, 6, 7, 8, 9, 10 centimeters squared. And now you have this many centimeters squared. So you put it here. 5 zeros. Always count how many zeros there are, because if you carry it wrong, then you will not be able to get a right answer. And then cross multiply, right? So x is equal to, put it into the calculator, 256,000,000 over, that's 110 zeros. And that will give you 2.56. So on the calculator it tells me it's 2.56 times 10 to the power of -3 kilometers squared. And it's up to you if you want to write it as, if you want to expand it. And we've learned how to do that, right? Scientific notations. So you take the decimal place to the left hand side 3 times. 1, 2, 3. So the point becomes here, so 0, 0 in the front. You'll have x is equal to 0.00256 kilometers squared. Okay. Next one. This many meters squared, 2 hectares. And we know 10,000 meters squared is 1 hectare. So I'll copy this down first. Or maybe I'll write 1 hectare is equal to 10,000 meters squared. And then you have 2350 meters squared. I want to find how many hectares that is. So you do cross multiply. X is equal to 0.235 hectares. Alright, that's question C. For question D, from hectares to kilometers squared. So from hectares we can only directly go to meters squared first. So 62, sorry, So 1 hectare is equal to 10,000 meters squared. That's what you know. And now you have 62.36 hectares. How many meters squared is this? Cross multiply. X is equal to, put it into calculator, 623600 meter squared. So that's how many meters squared. But it wants me to find kilometers squared, right? So you need to do another conversion now. We know 1 kilometer is 1,000 meters. So square both sides. So 1 kilometer squared is equal to, because there's 3 zeros, once I've squared it, it becomes 6 zeros, because 3 times 2 is 0. Oh, sorry, 3 times 2 is 6, right? So 1 kilometer squared is actually 1 million, so 6 zeros, meters squared. And now you have 623600 meters squared. How many kilometers? Once again, cross multiply. So 623600 divided by 1 million. X is equal to 0.6236 kilometers squared. That's your final answer. Alright, the next part is areas. So in the HSC exam, you'll be given these two formulas. And you'll have to recognize that the first one's for sector, the second one is for trapeziums. I guess there are some basic ones. So for rectangle, you do width times length. Squares, you do the side squared. Triangles, half times base times height. Parallelogram, because it's actually just made up of two of the same triangles, the formula is just base times height. There's no half, because they're two triangles. 2 times a half is 1, right? And trapeziums is half times a plus b, so the two bases. In a trapezium, to determine bases, you look at which two lines are parallel. The two parallel lines are your bases, and in this case it's a and b. And the height is h. So that's the formula. Rhombus is half times x times y. X and y are the diagonals. Circle, pi r squared. So make sure that you don't confuse pi r squared with 2 pi r. 2 pi r is the circumference, so this is in parameters, right? That's what you did yesterday. Pi r squared, just look at a square. Square means its area, right? So pi r squared. And now, the area of a sector. So once again, a sector is just part of a circle. How much of a circle? That depends on how many degrees. So theta over 360 degrees times the area of a circle, pi r squared. And the area of an annulus, so an annulus, we can also call it a ring. It's the shape that's made up of two circles, but one big, one small. And they share the same center. So from the center, I say that the smaller radius is r, the bigger radius is capital R. And I want you to find the area on the ring. So in this case, you're just finding the area difference between the big circle and the small circle. So you can just do pi r squared, the big circle's area, minus the small circle's area. Okay, let's look at some examples. I guess it's better if you just try these questions yourselves first, right? Because some of them you should be able to do yourself. So maybe give yourself 5 minutes before you come back to the second part of the video. Now these are my answers. Let me just quickly go through them one by one. First one is a trapezium, right? So for trapezium, you use this formula, half times height times a plus b. So now I identified that the two bases are 6 and 10 because they're parallel. And the height is 4, right? So you put these things into the formula, you get 32. Second one, I'm going to zoom in a little bit. Second one is a track. But as you can see, because it's got two half circles, you can actually just make them up to one circle. That's why I only used pi r squared here. because I see that it's two half circles. They make up pi r squared. And in the middle, it's a rectangle, right? So width times length, 50 times 30, and that will give you the answer. Question C, you're finding the shaded area, and we see it's a triangle. In the middle, we cut out a square. If you're cutting out anything, that means you're taking it away. So the whole thing is the triangle, half times base times height. The base, it tells you it's 24, and the height is 16. It doesn't matter if the height is outside. As long as it gives you these measurements, that's what you use. So half times 24 times 16 minus the square in the middle, 6 times 6. Next one, this is a ring, right? So for a ring, you use pi r squared minus pi r squared. The big R is, it tells you it's 15 for the whole thing. That means from the center, the radius for the large one is 15 divided by 2 is 7.5. For the small one, it tells you the whole thing is 2. So that means the radius is half of it, 1. And then I just substitute these two values into the equation, and I'll get the answer accordingly. Question E is a parallelogram, taking away two squares, right? Once again, take away and minus them at the end. So for the two squares, it's easy. 2 times 2 for each, and there are 2 of them. So 2 times 2 times 2. And for a parallelogram, you do base times height, that's all. So 12 times 8 is the whole thing. Take away the 2 squares. Last question is a sector. For this sector, it tells you the outside angle, 153. You need to find the angle inside, because that's what the sector's angle is, right? So you do 360 minus 153, it's equal to 207, and put them into the formula. You have the radius. Our next question. A local park in the shape of a rhombus. What's a rhombus? Rhombus is a shape, it's a parallelogram with all the sides equal. And it tells you the area is 72. How do we find the area of a rhombus? We do half times one diagonal times the other diagonal, right? That's outlined here for you in the table. So half times the product of the diagonals. So that means half xy, the formula, that's equal to 72, the area. We know one of the diagonals is 16 already, so half times, let's say x is 16, and we're trying to find y, right? So half times 16 is 8. Basically, you have 8y equals 72. So move 8 to the other side. Y is equal to 9 meters. So that's how long the other diagonal is. And what would it cost to cover this yard with new grass if the grass costs this much per square meter? So that means 1150 for 1 meter squared. What's the area here? The area is 72. How much do you need to pay? Right? So cross multiply. X is equal to 11.5 times 72. And that's equal to 828 meters squared. So that's the end of the explanation. Let me see if there's anything I would like to talk about in homework. So this is today's homework. First part is unit conversion. Second part, I think these shapes look okay. Yeah, so with these ones, you just need to find the shaded areas, right? So, for example, this one, for question E, this is a rectangle, take away a trapezium. For C, it's a square, take away a circle. For F, it's a track thing, take away a circle in the middle. So you need to recognize that. And for question 10, you just need to find the area of a sector. So you use the formula. And I guess this shape, 11B, looks slightly complicated, but then it's really 4 half circles. So there are 2 circles plus the square in the middle. E is a trapezium plus a rectangle, right? If you just draw a line here, you have a trapezium and a rectangle. Question D, you can also just cut it into a triangle and a rectangle on the bottom. So give it a go and see how you do with them. Question 15. So for the first one, you take away 2 circles really. Second one, as you can see, this one actually makes up for what's in the middle. This makes up for this semicircle. This makes up for this circle. And this semicircle makes up for the circle in the middle. So even though the shape looks really weird, they actually make up the whole square. So all you're going to do is 16 by 16. Right? Alright. So if you have any questions, just let me know.